All right, section 8.3. In this section, we're going to be proving triangle similarity by side, 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 and side, angle, side. Our objective is to use the side, side, side similarity theorem and use the side, angle, side similarity theorem, and then prove slope criteria using similar triangles. Okay. So what we're going to be doing today is looking at other ways of proving two triangles similar. Okay, in the last section, we know that we can prove two triangles similar using the angle-angle similarity theorem. In the last section, we had the AA similarity theorem. If I can prove two angles congruent to two other angles in another triangle, then the triangles are similar. Okay. Today our first theorem is going to be strictly looking at just the sides, okay, and not congruent sides. So again, this is very different than our side, side, side congruence theorem that was used to prove two triangles are congruent. Today we're going to look at if two triangles are similar. And we know similar triangles, their sides are proportional, meaning all their ratios are equal. So if the corresponding side lengths of two triangles are proportional, and again, what does proportional mean? Proportional means they have equal ratios. Proportional means equal ratios. And again, a ratio is just a division. Okay, it's just another word to mean the division of two numbers. So equal ratios, then the triangles are similar. So it's somewhat different than angle-angle, because angle-angle we only needed two angles congruent, not all three. But here we need all three sides proportional. So if I can prove that, again, AB over RS, because those are corresponding sides, is the same. So if I can show AB over RS is the same as BC over ST, there's BC over ST, and that is the same as CA over TR, CA over TR, then the two triangles are similar. So you need to prove all three sides. Okay. So here, in extra example 1, is either PQR or triangle STU similar to triangle VWX. So we're looking at this one, VWX. We're looking at this triangle. We're trying to decide, are either of these similar to it? Okay, so we need to be looking at those proportions. So to try to figure out how to set up those proportions, I always look at, okay, is there any side that's longer? So let's look at this one and PQR. Let's do those two first. So do I have any side that's longer? Well, in this one, VX is the longest side. Here, PR is the longest side. So we're going to look at that proportion. So we would have to do VX over V to X over P to R. Again, we're going small. This is the smaller triangle, and this is the bigger one. Okay, and we're asking ourselves, is that equal to? So you put a question mark above it. We don't know if it's equal to. Okay, so now we need another side. Well, the other two sides are congruent. They're both 8, so it doesn't really matter. We can go that side and that side. Okay, so is that to WX over PQ? And does that equal, and then our last side there, that green one, WV over QR. So now I just need to get all of these proportions. So we'll do WX, which is 12, over PR, which is 16. Does that equal, again, question mark, we're not sure it does, WX, which is 8, over PQ, which is 12. And does that equal WV? WV, which is 8, over 12. So now we simplify these fractions and see if they're equal. Okay, so 12 over 16, those both divide by 4. That would be 3 over 4. Here, these both divide by 4. That would be 2 over 3. So do they equal each other? I can tell right there, no, not equal, so we know not similar. I didn't even have to finish it. As long as I have one that's not the same scale factor, that's not the same ratio, we know they're not similar. Okay. So we know it's not similar to PQR. So we know it's not similar to that one. So now let's try STU. So STU. So now our longest side here is the 12. So here's the longest side, the 30. So I don't know, let's do small to big. We'll go 12 over 30. Okay, does that equal? Question mark. Next side would be the 8 over the 20. And does that equal the 8 over the 20? Question mark. So simplify each of these fractions. This is divisible by 6. 6 and 12 twice goes into 35 times. These are divisible by 4. 4 goes into 8 twice, goes into 25 times. Oh, and then same with that one. 2 or 5, they are all equal. So yes, triangle VWX is similar to triangle. So let's see, V would go with S, and then we went to WVWX, so this would go ST to U. Okay. So yes, VWX is similar to STU. Okay, all right, so here in example 2, find the value of X that makes XYZ similar to HJK. Okay, so first it might be helpful to kind of match up the sides. So this one's HK is 30. That's the longest side. That's going to match up to that longest side. Okay, so if we go, I'm going to go big to small in this case, big over small. Okay, so here 30 over, and this one's x minus 5, has to equal, now let's see, the very smallest side is this one. And the very smallest side is that one. And if we're going big over small, that has to equal 15 over 3. Well, even without this last side, I have now a proportion, a ratio, two ratios that are equal, that I can actually use to find x. Okay, I don't even need this third side because I've got an x in it already. So now I can just do means extremes. So let's multiply the means, the 30 and the 3. That gives me 90. Now sorry, those were the extremes. Let's multiply the means. 15 times x minus 5. It's times that whole thing, so I'm going to have to distribute. Okay, we need to make sure we have our algebra skills here. So I'd have 90 equals 15x minus 15 times 5. I'm not sure on that one. 75. Okay, so now I'm going to add 75 to both sides. 90 plus 75 is 165. Let's bring it over here. 165 equals 15x. Divide both sides by 15. X is equal to 11. Okay, so x is equal to 11 in this case. Okay. All right, so that was our side similarity theorem. If all 3 sets of sides are proportional, then the triangles are similar. Okay, so we have a way of knowing similarity if we know the angles. We have the way of proving similarity if we know the sides. Now we need a way of proving similarity if we know a bit of both. Okay, so now we have if one angle of one triangle is congruent to an angle of a second. So meaning I have congruent angles here. Okay, so here I have congruent angles. So here angle X, congruent angle M. Okay, and the lengths of the sides, including these angles, are proportional. What it means by including these angles, meaning the sides on either side of the angle. So we have to be looking at this side to this side. Okay, that would be the ZX to PM right there. That ratio has to equal the other side, the ratio of the other side. Okay, the ratio, okay, of the other side. You're not going yet, Zyle. Check the board. Okay. Okay, so of the other side. So sorry about that. Okay, I had a little distraction in the room, but we're back. Okay, so we have that other side. Okay. So it has to be on either side of that angle that you know. Hence the order side, angle, side. The angle has to be in between the sides that are proportional. So here the angle has to be in between the sides that are proportional. It has to be the included angle. Has to be the included angle to use side, angle, side. Okay, to prove that they're similar. The side, angle, side similarity theorem. Okay, so here, an extra example 3. The diagram is a scale drawing of a triangular roof truss. The lengths of the 2 upper sides of the actual truss are 18 feet and 40 feet. So the lengths of the 2 upper sides of the actual truss, so the big one, the big truss on the roof, okay, is going to have one side that's 18. So here, let's have this be the longer one, 40 feet, and this one's 18 feet. The actual truss and the scale drawing both have an included angle of 110. So this angle here is 110 on both. Is the scale drawing of the truss similar to the actual truss? So if you notice, this angle in here is congruent on both. So we have that middle angle. Okay. Now we need to determine, does the side on either side? Okay. Do we have that either side proportion? So basically we're checking to see, is this side in ratio to this one? So here we'll do this blue side, this blue one to this blue one, and this green one over here, let's do this green one over here to this one. Okay, so
students with RTIs should report.
okay.
Sorry. Students with RTIs should report to the usual place. Thank you.
I'm very confused. Sorry guys for all the interruptions. This video is just getting interrupted up the wazoo. Okay, today was a late start day, which makes it crazy. Okay, so first thing first is, if you notice here, this is in inches, this is in feet. So let's do some converting. Let's take that 40 feet times 12. This is 480 inches. Okay, and this is 18 times 12, so this would be 216 inches. So really we're checking to see, is the ratio of the blue, let's go big to small, big over small, equal to the ratio of the green. So we'll go big, so 480 over 10. Does that in fact equal the 216 over 6? I'm in the middle of a recording and I'm recording. Okay. All right, so we go 480 over 10, which is 48. And then we have 216 over 6, which is 36. So do we have the same scale factors? It'd be 48 over 1, 36 over 1. Those are not equal, so these triangles are not similar. Okay, whoever made that scale, whoever made this diagram of the scale drawing didn't do it with the accurate scale factor. Okay, so now go ahead and write your practice down here at the bottom and go ahead and get started.